Hello, this is Morgan Iannuzzi
and Amanda Bowe,
here to discuss the REEclaiming Energy Independence Interactive Web-Based Map that we prepared for our Dynamic Cartographic Representation class in the spring of 2011. It is designed to help analysts at the Department of Energy identify deposits of rare earth elements to develop into active mines. First, I will give a little background on rare earths and some of the relevant literature. Then, Amanda will give a demonstration of the REEclaiming Energy Independence tool. Rare earth elements, or REEs, comprise the group of elements from atomic numbers from 57 to 71 and number 39. These elements are crucial for producing components of green technology, such as rechargeable batteries used in hybrid cars, permanent magnets used in wind turbines, and fluorescent light bulbs. These elements are also used in the defense industries for lasers and night vision goggles. There are many other applications of REEs, including petroleum refinery and metal alloys. As can be seen by the two pie charts, China has the largest amount of REEs, 48% of the world's reserves, and controls 97% of the world's REEs production. Fortunately, the United States possesses 12% of the world's REEs reserves. This means it could support its own demand. In order to reclaim energy independence through renewable resources, the United States needs to develop active REEs mines. The mission statement of the U.S. Department of Energy is to use science and technology solutions to solve energy and environmental challenges. One of the energy challenges facing the United States is its dependence on China for the production of REEs. To solve this challenge and ensure that the United States leads the world in clean energy technology, the analysts at the DOE must understand and analyze the REEs resources within the United States. The analysts need a tool to visualize current deposits, explore development potential, adjust for differences in consumer demand, and determine optimal allocation of resources. To meet this need, we created the REEclaiming Energy Independence tool. This tool is based off of a Google Maps mashup. A map mashup combines geospatial information with sophisticated geographic web services, such as Google Maps. Google provides an application programming interface, or API, to allow the public to make use of their web mapping service, which is a set of code libraries for manipulating Google Maps. Nielsen provides some usability heuristics, user control and freedom, help and documentation, and aesthetic and minimalist design are the most relevant to this project. We incorporated these heuristics by including a reset map button, a help mode, and an accordion menu, which will be explained in the demonstration. A mashup can be combined with animation to display spatial temporal data. However, an animated map presents certain usability challenges. Harrower outlined 4 such challenges: disappearance, attention, confidence, and complexity. We addressed confidence and complexity. Confidence refers to the uncertainty users feel when faced with a new application. To increase the user's confidence, a short introduction was provided to explain the map's features. Many animated maps provide large amounts of complicated information. Dynamic querying through filtering allows the users to set and change constraints on multiple attributes and reduces the map's complexity. It empowers the user to focus on a reasonable subset of data, which can be shared with others to stimulate discussion. Furthermore, other graphics, such as a histogram, can be added to the application to improve confidence. With these geographic tools and principles in mind, we created the REEclaiming Energy Independence Map, which Amanda will now demonstrate.
A general interest screen provides an overview of the project and basic instructions for its use. The actual tool can be accessed by clicking on the View Map button. As you can see, the primary focus of the tool is the Google Maps mashup, which occupies most of the display. Plotted on top of this map are the 44 rare earth deposits currently known to exist in the United States. These points are color-coded based on the amount of time necessary to develop each deposit into an active mine, as shown in the legend on the lower right. Clicking on any single point will bring up an information window containing additional information about the deposit, including the deposit name, location, other minerals present, and the current ownership. The map display can be animated using the control buttons below. This animation shows the number of mines active at each time interval, 3, 7, 10, or 15 years, assuming development begins immediately. A linked histogram on the lower left displays the cumulative number of mines online at each time step, providing numerical data to supplement the visual trends shown in the animated map. This data can be used to confirm insights and increase user confidence. The histogram can also be used to view each time step individually, reducing the problem of disappearance. We also provided the user the ability to limit the data points displayed through the use of a filtering tool. This helps the users explore different options and reduces the complexity of the display, allowing the user to focus only on relevant data points. The filtering tools are found in an accordion menu on the left-hand side of the stage. An accordion was used to keep the display simple, allowing these options to be hidden when not needed. To begin exploring the data, 2 preset scenarios are included. The low consumer demand scenario uses all deposits which are relatively easy and most profitable to develop. These deposits contain heavy minerals and are either proved or probable reserves. The high demand scenario uses all deposits which could be economically viable, with no restrictions based on molecular weight. A Reset Map button will allow you to set the map back to its original position. From one of these current scenarios, and the initial reset as we just did, the user can modify their search by changing the individual filtering options. Radio buttons are used for the individual elements and their applications to focus on each item separately. Checkboxes are used for the molecular weight and status to include all categories which are relevant to user interest. For example, if the user was interested in finding neodymium mines for use in magnets that contain only light REEs, they would click neodymium, magnets, and deselect the heavy checkbox. As you watch the map, you can see that these mines are come online in a regular pattern, increasing the number of mines linearly as expected. Help and documentation navigation buttons are provided in the upper right-hand corner. The Back to Intro slide returns to the additional intro slide, and the Help mode button will activate the Help mode, which displays additional information about each feature and its use. You can return to the main map by clicking the green Back to Map button. All of these tools can be used to explore different scenarios for the development of rare earth mining in the United States and can aid in policy decision-making. As consumer demand for green technologies grows in the United States, there will be an increased need for rare earth elements. However, the production of REEs is currently dominated by China. To truly achieve energy independence, the United States will need to develop its deposits into producing rare earth mines, ensuring its own supply of these elements. Development of rare earth mines in the U.S. has been stalled for the past decade, and restarting this program requires significant planning. Policymakers need a way to analyze available deposits and explore different production strategies. It is our hope that the REEclaiming Energy Independence tool fulfills this need through the provided scenarios, filtering options, histogram, information window, and other features, and will enable the Department of Energy analysts to develop an effective strategy for resuming the production of rare earth elements in the United States based on available resources and anticipated demand.
This is Morgan Iannuzzi
and Amanda Bowe,
signing off.